Hello, everybody, and welcome to the latest session of Red Hat TV, the data services podcast and stream. My name is Randy Arsenault, and I'm very happy to be joined today by my colleague, Frank Lee. Frank is an IBM Distinguished Engineer and Director of Worldwide Tech Services and Tech Sales for the IBM Storage team. So, Frank, thanks for joining. So Frank is going to take us through a quick demo today to show off some of the capabilities of Fusion, specifically as it relates to advanced metadata management and curation, automated discovery, and things that we think are pretty significant and powerful differentiators of Fusion in the Kubernetes space. So Frank, thanks again for taking a few minutes today. I know you're a busy guy, so let's jump right in. Tell us what we're seeing.
Yeah, thanks, Randy. So I'm very excited to share this very latest use case and capability from Storage Fusion. In this specific example, we're using large amount of healthcare data, in particular, cancer imaging data. You can see here on the lower right, I have a browser accessing all the data in a S3 bucket on a public cloud. I have thousands of images. Lots of them are stored in probably 6, 7 level deep in these folder structure. Each folder can contain up to dozens and hundreds of images. So how can I access them? How can I analyze them? How can I manage and govern them? Is where we're going to use Storage Fusion to provide data cataloging service, and then integrating that with IBM's Cloud Platform data to provide the final visualization and analytics tool. So let's get started. So the first thing we're going to do is go to the Fusion data cataloging UI. You can see here I have a setup where I can browse, search, and also look at the metadata I already catalog. So I already set this up under the metadata panel. I can define what metadata I'm going to collect or scan. What are the connection I'm going to connect to. In this case, I'm scanning this S3 target. I set up the cluster, the data source, this bucket name, right? I also put in the credential. Now, since I can do this very quickly, I can come back here and show you what I have scanned for. So I can already see the bucket is scanned. I have 7,925 images. I cannot access in a single button click. I can just click right here. You can see I have a individual listing of all the images shown in the catalog now. I have the path, the bucket name, the file name, which contain the full path to every single image.
Okay.
I also can break down the file type, the bucket name. This M time is very interesting because it can actually tell us when's the last time the file was created or modified. Access time can show us when the file was last opened or accessed. I can also tag the data. In this case, I can create custom tag. For example, I already tagged them with this session ID. Right? I can quickly change it by selecting the path and then effectively selecting all 7,925 files and then modify the tag value without actually going to the bucket or changing the name of the file, right? Or creating a separate CSV file. So you can see I can just say add a tag. Right? I can just pick a tag. In this case, I can pick tag data set, this metadata tag, right? Put a value here. I can say OCP, TV, live, and I can submit, right? So after a couple of seconds, a policy was created.
Nice.
You see now I can tag all these 7,925 files, right, with a single, almost like a simple click. Right? I can come and see if they are already updated.
And some of this metadata is automatically developed by the implied structure of the file set, right, or the data set.
Exactly. So we actually have tool building to the catalog to extract valuable metadata out of existing, let's call them raw metadata. For example, we can extract using a policy this value. For example, I can extract this patient ID here automatically, or this 400x, right, magnification, file type, which is already here, right? And even, diagnosis value and cancer type. And these can become additional tag we can use to enrich our catalog.
Yes. Very cool.
So what can we do with this, right? So once we have these very rich, updated customized metadata. We can then use a variety of means to consume this. One of which I'll show you is to export out as a manifest. So what you can do is you can select, for example, this 7925 file again. We can say generate report. This will allow us to create a manifest. So we can say manifest demo. You can submit. What this will do effectively, it would take what we selected here and create a manifest. So by manifest, I mean it is a simple file that contains all the metadata, line by line, right? Including all these values, metadata values. So we can come to the metadata tab here, look at the report, actually search reports. You can see we already have a report called manifest demo. So what we can do is we can click on this and then download the report. Now, once we download the report, we can actually look at what the values are directly in this file. You can see everything you have been seeing on the portal, but now it's in your your client device, right? Your desktop or your laptop, even on your mobile device. So once you have this manifest, think of this as a miniature of your data set, right? A representation of your data set. And you can use this manifest to visualize and analyze your data now. So what we can do next is I'm going to show you, you come back to the bucket again and go back to the top level. Here's another bucket that we can upload the manifest. So we'll use this bucket here called UDF3. So we're gonna upload the manifest here, which I already did, right? I already uploaded this here before the demo. So it's just this file, effectively the same as this one. So this file now is also globally available to our downstream data platform called Cloud Platform. So what I'm going to show you next is I'm going to come to a platform called Cloud Platform Data. So let's come here. So this is a view of the Cloud Platform Data, which will upload or access that manifest. So if for interest of time, what I'm going to show you is just go directly to the project. So we'll go to the projects. UDF3-1. This project is a collaborative space running in the cloud that now I can see all my data and data assets. So this file right here is the file I just uploaded. Right? I can click and see, you can actually see it's identical to the CSV file I just created, right? So it has all the metadata element generated by Fusion, file type, data source, right? I can even rebuild a URL directly to the file, which will become useful. The next thing I can do is I can come back to the project. I can use tool building to Cloud Platform Data called Data Refinery to generate additional manifest. For example, here's a manifest integrated with patient ID. Actually, it's a different one. Come back here. So in other words, I can take additional information such as patient name, patient information, and integrate this with the manifest I just uploaded, right? So here you can see I have the patient ID, location, gender, age, right? And also the value I extracted from the manifest, benign, right? Different cancer type, the magnification, and the tissue. So you can see how I can create additional useful information to do what? So this is where this really becomes interesting, this demo, is now if I come in as a data scientist, I used not to be able to have access to data, right? I have to ask ask Randy, for example, can you help me get the data sets that I'm going to import into here, right? I'm going to do everything in my ability to analyze the data. Now, all of that is done in a matter of, say, 5 minutes you just went through, right? And then now you have a manifest. You can look at the data.
Yeah, and just a quick question. So up to this point, all these precursory steps, you don't have to be a domain expert or have specific knowledge of the data, right? This is all just tooling and instrumentation that's easy to automate, right?
Exactly. What Fusion provide is that abstraction, right, of the raw data with a manifest, right? Fusion had direct access to the data and generate the catalog, generate the manifest. And that can be done by a data engineer, a data steward who is much in line, in tune with, right, the data source, and then create these catalog that can be consumed by data scientists. Well, you're absolutely right. Does not even have to know where the data is stored, right? Yeah. But now the data scientists come to work. So they can click on this visualization engine. So what this visualization dashboard does is a bunch of service that actually already created one. So we built a full dashboard that allow the data scientists to actually access data. So the first dashboard is just to be able to access the data, right? So for example, we can actually take the metadata, rebuild the direct URL to the file itself. So now they can click on this URL and actually directly visualize the image itself, right? So now this image file is not imported into Cloudpad for data.
Right.
It's just a link.
It's just referenced by the URL.
Yeah.
Okay.
Now you can see data is everywhere. It can be in a public cloud. It can be on-premise in a data lake, right? Could be sitting on a storage scale file system or Ceph. But now with this catalog, we're connecting the visualization directly to the data source, no matter how much data are there.
Yeah, that's really cool. So,
now, yeah, go ahead, Randy.
Just great example of the kind of workflow, the simplified workflow with Fusion working in conjunction with Cloud Pak for Data in this particular use case.
Exactly. Now the data scientists will ask more questions, right? Because now they want to analyze the data set. For example, they might look at if I have this much data, right? Especially I'm interested in high resolution data, 400x magnification. How much of that data is distributed based on the cancer or tumor type, right? So they can use the query engine or a shopping cart experience dashboard on the right. They can click and select, right, different tumor type, and then see the distribution of the data right in front of their eyes, right? So at this point, they're no longer accessing the original storage or data, right? They're just working with the manifest and using the dashboard.
Yeah.
They can also ask questions now for patients. For example, now they can look at the distribution of different cancer by age, right? In this particular case, this is a tumor type, a ductal carcinoma. There are 6 patients in there, right? Each patient have different age. Now they can look at the age distribution of the data set and do what if type of analysis.
So this would also have an important, I guess, security consideration as well, right? Because they're able to operate on the metadata without touching what might be a secure data set or data source that lives elsewhere.
Absolutely. Yeah. We can also apply data governance and data privacy rule to the dashboard, right? For example, we can limit certain column to, for example, remove the risk of exposed patient name, right? Patient actual birthday, or even location. Now, there might be a need to look at the location, for example, to look at the geo-based risk.
Public health implications.
Right. But the analyst needs to have the right permission to access the right data at the right time.
Yeah.
Which brings us to the last dashboard, which is look at the location, right? So for example, in this case, if the analyst has the full clearance to look at the entire data set, which includes the diagnosis, the age, and also location, the dashboard allows them to do that by plotting the data out on the geospatial visualization map, right? You can zoom in and zoom out, look at different patients, the distribution.
Different clusters and locations, yeah.
Yep, you can actually see clustering now, right? You can look at, for example, the age, impact on the distribution, the different tumor. Let's pick, for example, the most common one, ductal carcinoma. You can just use that, right? Look at all the data. And then couple that with, for example, you can narrow down the age, right? For example, 60 and 57-year-old. You can see the graph change almost on the fly. Right? So this really showcased the power of connecting data to visualization, right?
Yeah,
To make
yeah.
that happen in real time, Fusion really play a critical role by connecting and building that bridge.
Very cool. Yeah, and obviously, you can imagine an unlimited number of other possible use cases for this, whether it's cartographic analysis, financial analysis, loan rating. I know we did a big project some years back for wildfire identification and prevention, so there's a million possible use cases. But just to see how easy that was, the whole flow from the start to the actual visualization is really remarkable. So
Absolutely.
that's
Good point, Randy.
very cool.
Yeah, so lots of data everywhere, large
Yeah.
data sets, right? Millions of files. If you're going to train, for example, a regenerative AI model, you're going to be dealing with millions and possibly billions of files, right?
Yeah.
Fusion
Yeah.
made that possible by helping you creating a catalog
Yeah.
and make it available for the analytics platform.
Very cool. Very cool. All right. Well, this is amazing and timely. So HIMSS is this week. This will be something that'll be a pretty attractive thing to view at HIMSS, I'm sure. So
Yeah, absolutely. Yeah, I'm gonna show that tomorrow at HIMSS in
yeah,
Chicago.
nice. All right. Well, this is great, Frank. Thanks for taking us through this demo. I think it really showcases the workflow and the ease of operation and the clean interoperability between Fusion and Cloud Pak for Data. Of course, the same applies to other Cloud Paks as well. But this is a really cool visualization example. So thanks for sharing it. Appreciate
I'd like to thank Joe Dane and Frank Greco for helping us building this demo.
Yeah, great stuff. All right. Well, thanks, Frank. We appreciate it. And hopefully we'll catch up on a future episode as well. So safe travels and thanks again.
Thanks, Randy.